Hello everybody. A little while ago I had posted this little short which shows how I use a little device with a camera to monitor the water usage in my house by reading out the analog water meter. After the short was live, I got a lot of questions. How did you do this? How does it work exactly? How can I do it myself? Behind all that, there is an open source project which is called AI on the Edge. It's a great project and it also has a great description online. But even though I thought, because I got so many questions, it would make sense to create a little video about this. So let's jump right in.
Smart home maker, rock the beat. Innovation at your feet. Build it up, don't complicate. Home solutions, you're the mate.
So what do we need to get this project started? First of all, we need an ESP32 CAM dev board. This is a specific ESP32 board which comes also with the possibility to plug in a little camera. Usually this little camera is also included in what you buy online, and also it comes with an SD card slot where you can place an SD card that is useful in order to store images. The second thing we need is either a USB to UART bridge, just a classic USB to UART bridge. Many of you might have this already at home. It's usually also called something like FTDI 232 because FTDI is the manufacturer of such a device. Or you could get a USB adapter specifically for this ESP32 CAM board. Many ESP32 CAM boards already come with such a USB adapter, so this could be also used, but then this is not so versatile and cannot be used for other projects as well. Furthermore, we need a micro SD card, which is used to store data. We need some jumper wires, and we need a 3D printer and some filament in order to be able to print the housing. Or if you don't have this at home, you could also print the housing at an online service. With all these ingredients available now, we can start and jump into the project. The next thing we have to do, in case we have a USB to UART converter, is to connect the wires. If you don't have such a USB to UART converter, but just a USB to ESP32 CAM adapter, you don't need to do any wiring here. You can just skip over this chapter. But if you have to connect your USB to UART converter, you first have to make sure to power the ESP32 CAM. There is two possibilities here. Either you go for an external power connection, which is usually more stable, or you can also power the ESP32 CAM device directly via the USB to UART converter. In my case, this always worked, but it can also not work so stable in some situations. If you want to power it via the USB to UART connection, then you just connect the VCC output of the USB to UART converter with the 5 volts input port of the ESP32 CAM board, and also connect ground with the ground pin, or with any ground pin actually. The second thing you have to do is to connect the UART pins. So you have to connect the TX output of the USB to UART converter with the RX input of the ESP32 CAM device, and also you have to connect the RX output of the USB to UART converter with the TX input of the ESP32 CAM board. It is very important to connect this correctly, because the UART protocol works in a way that on the one side you write data and on the other side you receive data. So you have to connect the writing pin, which is the transmit pin, with the reading pin, which is the RX pin on the other side, and vice versa, because otherwise it won't work. And then we additionally need a temporary jumper cable between the GPIO 0 pin and the ground pin, because this is needed in order to bring the ESP32 CAM board into the bootloader mode in order to be able to install the firmware on the device. I will explain this later on when we are at the point where we need to install the software. So in this situation you need to temporarily connect this GPIO 0 pin with the ground pin in order to be able to install the software, and then you have to remove it again during the software installation. Here you can see how this looks like for my ESP32 CAM device with my USB to UART converter. We can now connect the device via USB to our computer and then follow up with the setup process. Now let's go through the web installer for the AI on the Edge device. You can find the URL to the web installer in the official AI on the Edge documentation or also in the description of this video. For the installation, it is very important that you set the ESP32 to bootloader mode. This can be done usually by pressing the reset button on a normal ESP32 dev board, but this board doesn't have the reset button, and that's why we will just make sure that we short circuit GPIO 0 to ground. We can use a normal jumper wire for this. Here you can see that I use a white jumper wire and I connect ground to the GPIO 0. And during the installation you have to quickly plug it in and then pull it out again in order to set the device into bootloader mode and then start the installation. But you have to make sure that you also pull the cable out again, otherwise it won't work. Now let's start the installation. I will now connect the device via USB and click connect. Here we see my USB to UART device, which is connected to the ESP32 CAM, and I click connect. Now I have to make sure that when I click install, I press the boot button, which means I have to quickly short circuit the GPIO 0 pin with ground. Now do you want to install AI on the Edge version 15.7.0? All data on the device will be erased, that's okay. Install. Now it's preparing the installation and it's erasing. Now I pulled also the GPIO 0 to ground connection again and the installation will start. We can fast forward this. Okay, the installation has been finished. Now it's wrapping up. And the installation was complete. Before we can continue with configuring the software, we have to adjust some hardware things. One thing that is important is that the lens has a specific focal point and we have to adjust that so that the camera can be placed directly above the water meter. For that we have to use a little knife in order to remove the glue between the lens adjustment and the lens, as you can see in the video. Before we can use the AI on the Edge device, we have to create a holder for the device that holds it on top of the water meter in a way that it can read out the water meter completely. And in my case I used this file here from Printables and just put it on my 3D printer. This is a really nice file, I think, and you can see this provides such a kind of holder here, and then it has a lid and another lid which you can place on top of the ESP32 CAM. So you have this lid, and in the lid you put your ESP CAM and it is face downwards so it can read out the water meter, and then you have this little lid here which helps you to make sure that there will be no dust or something coming to your camera. You can also have a closer look into the model. You can see this is this little lid. This is the bottom lid where you put the ESP CAM device in, and here's a possibility to get into it with the power cable. The only problem I had with this housing here is that this upper lid was kind of too small for me, because my ESP32 cam device has some soldered on pins, and I also wanted to use jumper cables to connect to those pins. And if you use jumper cables, this, it makes it high, because those cables look out here, and then you can't close this lid anymore. So what I did was to create my own lid for this. This lid is just a little higher, as you can see here, so that I was able to plug in the jumper cables into the ESP cam device and then go out through the little hole here with those two cables. And what you can also see here is my first prototype, where I still had this USB to UART device to power the ESP32 cam device. But I can show you now how you can just make a nicer solution by just using a standard USB cable and then just soldering some two little cables to it, which can then be used to power the device, so that it looks a little cleaner and you don't have an open kind of PCBA hanging around here, because this could be also corroded or something after a certain time. After printing the housing and placing it on the water meter, it should look like this. And you can also see the little lid that is placed on top, so that there will be no dust. Next thing you have to do is to prepare an SD card with a certain file structure, which is used by the ESP32 cam device in order to store images and other information. The easiest way to do this, from my point of view, is to use the remote setup using the built-in access point. It works like this. You download the AI on the Edge device remote setup zip from the release page to your computer. It could be a desktop computer. Then you have to connect to the access point of the AI on the Edge device. So for this, of course, the ESP32 cam module needs to be powered on. And then it should expose a hotspot, which is called AI on the Edge. You should be able to connect to this and just access it without any password. But be aware that once you connect to such a local access point with your computer might not be able to access the internet anymore. This is just an important information, because if you want to reload the documentation or whatever, at that point in time it's not possible. Once you've connected to this hotspot, the device will expose this IP address as a fixed point that you can open, and if you open it in your browser, you should get such a page here, which allows you to upload the initial configuration to the SD card. So you can just browse and then upload the file that we have just downloaded, the zip file, in order to put it on the SD card. Then it will also ask you to provide your Wi-Fi credentials. So here you just type in the Wi-Fi SSID of your home router or your home Wi-Fi that you want to connect the device to, and your Wi-Fi password. Once you've done that, you can just reboot the device and the initial setup should be finished. The reboot can take up to 3 minutes. After the reboot has been finished, the device should connect to your local Wi-Fi network. It will show you also a Wi-Fi status indication with the LEDs. If the LED is blinking 5 times fast, this means the connection to your Wi-Fi network is still pending. If it's blinking 3 times slowly, it means the Wi-Fi connection has successfully been established. Okay, once the reboot is finished, the device is connected to your Wi-Fi network. It has been assigned with an IP by your home router. You should be able to look it up, and with this IP, typing it in the browser, you should be able to open the initial setup page. This is how it looks like. I can't show it to you because my device is already set up. But during the setup process, you will take a reference image. This is a first image of your meter, and this reference image is used to place some markers on that image. The best way to explain those markers to you is by using my own actual meter, which is already configured. Here you can see that we have two kind of reference ROI markers. Those are used in order to indicate a certain point on the image, which the AI on the edge device can use to kind of recalibrate the image a little bit. Because it could be that by someone who is walking by the device, it was moved a little bit up or down. So the image is not exactly in the same position anymore. And then those reference marks here help AI on the edge in order to kind of shift the picture up, down, left, right a little bit. Then we also have the markers for the large digits, which indicate, in my case, the actual cubic meters that are used. So you have placed those markers here so that the AI on the edge device knows which part of the picture to cut out and to use for identifying the numbers. And additionally, you can place the markers on those little analog kind of clocks here, and those indicate the subdecimal places. So for example, you can see here, this one says times 0.1, this one says times 0.01, this one times 0.001, and this one times 0.0001. So you see, those are the subdecimal places, and AI on the edge is also able to identify those. So you place all these markers here, and then the initial setup should be finished. Once you've configured your regions of interest, the system can start processing the images taken from the water meter. You can see here at the moment I have a previous value of 157.9085, and the system is now taking a new picture and it is currently aligning, and when I refresh it should show you that now it has recognized again and has updated the value and is now finished with the flow. But now the data is only on the ESP32CAM device, but we would like to transfer this data to our Home Assistant instance. How can we do that? For this, you can configure an MQTT connection to Home Assistant. So you can go to Settings and then Configuration, and then scroll down, and at the very bottom there is a section called MQTT, and here you have to define some URL. So in my case this is homeassistant.local and the port is 1883. Then you have to find a main topic. This is the MQTT topic where the MQTT messages will be sent to, and an MQTT client ID, and below that there is the username and the password, which I don't want to show you now. That's why it is not, I'm not scrolling further down. But once you have configured this MQTT information, the smart water meter device will now send over the data to Home Assistant, where we can process it further. Now let's head over to our Home Assistant instance and open the configuration.yaml file. And here I define a new or two new MQTT sensors. One sensor is called water meter value, sorry for it being German. And this has a state topic of water meter, which is the main topic we have defined in the water meter. And then we have main/value. And a second sensor is water meter rate, with the state topic water meter main rate. And the unit of measurement is for this sensor cubic meters, and for this sensor it is cubic meters per hour. And this rate can be really useful, because if the rate is very high, that means that at the moment a lot of water is going out of your pipes. So this could maybe help you to identify a water leak, or it could help you to identify whether someone is taking a shower at the moment if you want to trigger automations based off that. Of course, restart your Home Assistant instance in order to make the new MQTT based sensors work. And if everything works correctly, you can see that there will be new data in your sensor. And here you can see exemplary values. This is the water meter value, this is the water meter rate. And you can see now it's early morning. So at night we had a value of 157.880, and then nothing happened during the night, which is plausible because everybody was sleeping. And then at some point I was getting up, as you can see here, and I was taking a shower. So it's jumping up. And after that I was brushing teeth and all that stuff. So you can see that it works very well. And here we can also see the rate. And here you see, push, it's really jumping up and then it's going down again. And such a peak can help you to identify whether someone is taking a shower, or maybe if there is a water leak in your house, etc. So this is really nice. So now we saw this is already really nice, but I want to be able to also display the water consumption in my energy dashboard in Home Assistant. And for this, I need a further template sensor, and such a template sensor is called water meter value total here. It's a template sensor of device class water, state class total increasing, unit of measurement cubic meters, and then the state is just the state of the water meter value, and then also converted to a float. So that's all you have to define. And then once you have restarted your Home Assistant instance, you can also add this value to your energy dashboard. I'll show you how to do this. To add the water consumption to your energy dashboard, you go to settings, and then you go to dashboards, you go to energy, and then you have all of your different settings here. But the important setting is the water consumption here. And here we add the water meter value total. This is that additional template sensor we have just created. And if you've done that, you can now go to your energy dashboard. It will take a little while for the first data to be processed, but then you should see, if we go down here, here's our water consumption, and you can see that during the night nothing was going on. This was the evening when someone maybe went to the bathroom or whatever, and here is the morning. This is my shower in the morning. So you can see that it works well, and it is also now included in my energy distribution card here. So this is really nice, and I think this is really helpful. I hope you liked this little tutorial and it helps you to create such a nice solution for yourself. If you have any remaining questions or remarks, then please leave a comment below the video. And if you like the video, of course, it would really help me if you leave a like and subscribe to my channel in order to get also notified about my upcoming videos. See you next time. Thank you and bye bye.